Have you ever looked up at Jupiter, that giant, beautiful planet, and wondered what secrets it's hiding beneath those swirling clouds? We've long known it's a gas giant, a king in our solar system, but recent discoveries are showing us it's even stranger and more dynamic than we ever imagined. And it all comes down to something you can't even see, its magnetic field. For years, we had a pretty standard model for how planetary magnetic fields work. Deep inside a planet, a molten, metallic core spins, creating a giant electrical dynamo. This dynamo generates a magnetic field, usually with a neat north and south pole, kind of like a giant bar magnet. Earth has one. Saturn has one. We thought Jupiter did too, just a much, much stronger one. In fact, Jupiter's magnetic field is the most powerful of any planet in our solar system, nearly 20,000 times stronger than Earth's. But then, NASA's Juno spacecraft arrived. Juno's mission is to orbit Jupiter, swooping in closer than any spacecraft before it to peer beneath the cloud tops and unlock the planet's deepest mysteries. And one of the first things it measured with its incredible instruments was the magnetic field. What it found completely shattered our old ideas. Jupiter's magnetic field isn't neat and tidy at all. It's a mess. Imagine you have a simple magnet. It has a clear north end and a south end. Now, imagine you take another magnet, a smaller one, and stick it onto the north end of the first one, but kind of sideways. That's a simplified way of picturing what Juno found at Jupiter. The magnetic field in Jupiter's southern hemisphere is fairly normal, what we'd expect from a planetary dynamo. It has a distinct magnetic south pole. But the northern hemisphere, it's a whole different story. Instead of a single, clean magnetic north pole, the field in the north is jumbled and complex. Juno discovered that the most intense part of the northern field isn't at the pole at all. It's a huge, concentrated spot of magnetic energy located near the equator. Scientists have nicknamed this spot the Great Blue Spot. It is so dominant that it makes the entire northern magnetic field look completely different from the southern one. The field lines coming out of the north are tangled and do mirror the lines going into the south. The whole thing is incredibly lopsided. This discovery was a huge shock to planetary scientists. It meant our textbook models of how dynamos work were too simple. Something unique and powerful is happening inside Jupiter. So, what could cause such a bizarre, asymmetric magnetic field? The clues seem to be pointing deep into Jupiter's interior, to the very nature of its dynamo. On Earth, our dynamo is generated in a core of molten iron and nickel. But Jupiter is a gas giant. It's mostly hydrogen and helium. So, where does it get its dynamo? Deep inside Jupiter, the pressure is so immense we're talking millions of times the pressure at sea level on Earth that it does something incredible to hydrogen. It squeezes the hydrogen atoms so tightly that their electrons break free and can move around. This state is called metallic hydrogen. It's an electrically conductive fluid, just like the molten iron in Earth's core, and it's this vast ocean of metallic hydrogen that powers Jupiter's colossal magnetic field. The strange, lopsided nature of the field suggests that the dynamo process isn't happening uniformly. One theory is that the transition from regular molecular hydrogen to this exotic metallic hydrogen isn't a smooth, simple boundary. Instead, there might be a fuzzy layer where elements like helium, which don't mix well with metallic hydrogen under these conditions, rain down from above. This helium rain could disrupt the flow in the upper layers of the dynamo, creating turbulence and strange eddies in the northern hemisphere, while the deeper parts of the dynamo in the south remain more stable. This could explain the stark difference between the two hemispheres: a chaotic, messy north and a relatively calm south. This finding is huge because it gives us a window into the inner workings of a gas giant, something we've never had before. But the story gets even more exciting. A lopsided, unstable-looking magnetic field has led some scientists to ask a mind-bending question. Could Jupiter be in the middle of a magnetic field flip? You might have heard that Earth's magnetic field flips. Over hundreds of thousands of years, our magnetic north and south poles wander and eventually switch places. It's a natural, albeit dramatic, process. During a flip, the main field weakens significantly, and multiple smaller, temporary north and south poles can pop up all over the globe. The field becomes complex and chaotic. Sound familiar? That messy, multipolar structure is exactly what we're seeing in Jupiter's northern hemisphere. So, is it possible that Juno arrived at Jupiter at just the right cosmic moment to witness a planetary magnetic pole reversal in progress? Seeing a planet mid-flip would be an unprecedented scientific opportunity. It would be like a geologist getting to watch a mountain range form in real time. If Jupiter is indeed flipping, the Great Blue Spot might be a temporary, powerful magnetic pole that has emerged on its way to a new configuration. The more normal southern hemisphere might be the last remnant of the old field, which is slowly fading away as the new one takes over. Of course, we can't be sure yet. Planetary processes happen on geological time scales far longer than a human lifetime or even the entire history of science. A magnetic flip on Jupiter could take thousands of years to complete. We might just be seeing a snapshot of one chaotic moment in a very, very long movie. Another possibility is that this isn't a flip at all. Perhaps this is just Jupiter's normal state. Maybe the unique conditions inside the gas giant, the helium rain, the immense pressures, the rapid rotation naturally create a dynamo that is permanently lopsided and chaotic. Maybe Jupiter has never had a simple, bar magnet-like field. In this case, Jupiter isn't the exception to the rule. It's showing us a completely new rule for how dynamos can operate in giant planets. Either way, Juno's discovery has thrown open the doors to a new era of planetary science. It's forcing us to rethink our fundamental theories about how planets work from the inside out. Every new orbit Juno completes gives us more data, helping us map this incredible magnetic field in greater detail and test these amazing theories. Is Jupiter's dynamo simply built differently? Or are we witnessing a once-in-a-million-year event, the slow, majestic reversal of the most powerful magnetic field in our solar system? The answer is still hidden deep beneath those beautiful, stormy clouds. But with every piece of data Juno sends back, we get one step closer to solving the magnetic mystery of the gas giant. It's a powerful reminder that the universe is always full of surprises, and our journey of discovery has really only just begun. Thanks so much for watching. If you're as fascinated by the secrets of our solar system as I am, make sure to hit that like button and subscribe for more adventures into the great unknown. Let me know in the comments what you think is happening inside Jupiter. See you next time.